So today we're going to talk about bias and harm that can be perpetuated by AI systems. And I have a more expansive view of what those harms can be. So I'm going to spend a lot of time talking about them. But don't lose me, because I'll also talk about what we can do about these harms and how we can make sure that our products won't perpetuate these harms. So we want to create AI systems that benefit the people we serve and mitigate how harmful they can be to them. This bias or harm can enter at many different points in the product lifecycle from the beginning, right? The most important question we should ask is whether or not we should build a particular product. And if we don't ask that question, and if we don't have the voices of people who are marginalized groups ask this question, we'll miss the potential harms that we could have with a product that we build. And so it might be too late later on to make it quote unquote fair. After we start building the product, then of course we might have to annotate and gather data sets. We might have to build a model, and we have different metrics to determine whether this model quote unquote works or not. And even the way we evaluate whether our model works or not, that can be laden with bias, right? What does it mean to work? For whom? Who is it using it on which population? So in summary, we have to think about bias as something that is much more expansive than equalizing a specific metric across different demographics. So I'll spend a lot of time today talking about the different ways in which this harm can be perpetuated. And then towards the end, we'll talk about how we can avoid some of these harms. Let me now start with having you imagine a future. So I'm going to be reading you two different quotes by two different people. And this is an imagination of a future full of sensors that, one of them might think is very useful and the other one might think differently. So let's read these two different quotes. This one is called The Potential of AI. Imagine for a moment that you're in an office hard at work. But it's no ordinary office. By observing cues like your posture, tone of voice, and breathing patterns, it can sense your mood and tailor the lighting and sound accordingly. Through gradual ambient shifts, the space around you can take the edge off when you're stressed, or boost your creativity when you hit a lull. Imagine further that you're a designer using tools with equally perceptive abilities. At each step in the process, they riff on your ideas based on their knowledge of your own creative persona, contrasted with features from the best work of others. Doesn't this sound nice? This sounds like a great future with AI, working with you, riffing off on your creativity, trying to help you out. If you're tired, trying to make you feel better. This same office that we're talking about is imagined very differently by another person. This is another quote that I'm gonna be reading you. And this says, someday you may have to work in an office where the lights are carefully programmed and tested by your employer to hack your body's natural production of melatonin. Through the use of blue light, eking out every drop of every energy you have while you're on the clock, leaving you physically and emotionally drained when you leave work. Your eye movements may someday come under the scrutiny of algorithms unknown to you that classifies you on dimensions such as narcissism and psychopathy, determining your career and indeed your life prospects. Now, this is a very, very different future imagined by this person. The same technology, different future. And what's the difference? This is by someone who has experienced a lot of marginalization in their lives. So they can imagine how one future imagined by someone with a lot of privilege can actually be very detrimental to them. If you don't have perspectives from people like this, though, you'll probably only imagine the future that will be benefiting people in dominant groups. So this idea that algorithms can determine your career and your life prospects is not some futuristic science fiction scenario. It is something that is happening right now. There are a number of companies that purport to determine people's characteristics based on their photos. For instance, there are companies that say that by looking at someone's photo, they can determine whether they have a high IQ or not. By looking at someone's photo, they can determine whether they're more likely to be a terrorist or not. By looking at someone's photo, they can determine whether they are happy or sad. There are some companies that take it further, that they, for instance, record people on camera when they apply for jobs, and they give what they call verbal and nonverbal cues to the potential employers, in addition to the answers to the interviews. Now imagine you apply for a job. You didn't even know that there is any sort of artificial intelligence involved in your application process. You didn't know that there is something called emotion detection that, in my view, is very questionable technology that is involved in your job application process. And then because of what that model says about you, maybe it says you're just always angry, you might not get a job anywhere in the world. A 1 point of failure. Imagine that because of some training process, that you might be classified as a terrorist by some sort of algorithm. So these are things that are happening right now today. They're not at some point in a very distant future. For example, even if you don't try to classify people by these different dimensions, even if something works as intended, right, you can still use it to persecute people. This happened in the United States during protests, protesting police brutality, killing of unarmed Black men, for instance. And what happened is that police were using face recognition systems on protesters. And so what they would do is, when they identify those protesters, they try to match them with their social media profiles and then see who has outstanding warrants and then go persecute them. So this would have a chilling effect on a person's civic duty to participate in democracy and protest injustice, right? So it's not just about misclassifying people or doing something that's not intended. Even when the technology works as intended, it can be used to persecute people. So for me, this is part of the definition of bias or harm. It's not just about something that doesn't work well on some people versus others. It's also how it's used and on whom. Mimi Onuha, who is an artist, I highly recommend that you check out some of her work, said, every data set involving people implies subjects and objects, those who collect and those who make up the collected. It's imperative to remember that on both sides we have human beings. So every time we talk about technology, whether it's artificial intelligence or something else, we have to remember it's human beings who create it, it's human beings who use it. Sometimes in my field, in computer science, in AI in general, artificial intelligence, people forget that. So Sita Pena, who is a social scientist at London School of Economics, says this. She calls it the problem with abstraction. She said, I have heard computer scientists present their research in relation to real-world problems, as if computer scientists and their research is not done in the real world. I listened to papers that tended to disappear people into mathematical equations. Marginalized people are demonized, deprived. What is the point of making data-driven systems, quote unquote, fairer if they're going to make institutions colder and more punitive? So for instance, what's the point of making face recognition work well on everyone if that means that people are just going to be more persecuted, right? So we have to expand our view of what it means to create harm and bias. So I want to give you a few examples here, and I'm going to base these examples from my own work with my collaborator, Joy Bulamini. So here we're looking at a chart, and this chart shows an excerpt from our paper. And what we did in our paper is we looked at automated facial analysis tools like those that do many things, for instance, face recognition. And in this case, these tools look at a photo and determine whether the person in that photo is a male or a female. So a binary attribute. And they don't distinguish between gender and sex labels. And there's already a whole bunch of assumptions baked into the task itself, which we'll talk about later. So in this chart, we're looking at the results of our audit of these systems. So the darker and darker the skin tone, and this one is specifically for women, the higher and higher the error rates. So if you flip a coin and you just guess, you don't know whether the person is a male or female, your accuracy would be 50% chance, right? It's basically guessing. So here we're seeing that the darker and darker the skin tone, some of these tools actually approach random chance. So when we came out with this paper in 2018, it had a splash. A lot of people fixated on the inaccuracy, right? Because the accuracy for lighter skinned men was very, very high. The accuracy for darker skinned women was much lower, much lower, approaching random chance. So what does this mean? This means that, for instance, if we look at high stakes scenarios, for instance, if face recognition was used to determine who committed a crime, that Black people would be much more likely to be misidentified, right? And we foresaw this in our paper. And in fact, in Detroit, there was the first case of someone being wrongfully arrested because they were misidentified by a face recognition system. And so this happened to a Black man, which our paper foresaw. A lot of people, in my view, kind of didn't get the whole point of our paper, right? They fixated on the fact that these systems are much more accurate for lighter skinned people than darker skinned people, but they didn't think about, for instance, the task design. What if it was accurate on everybody? Does that mean that it would be fair? It wouldn't be fair. But many of us were, I would say, fixated on kind of how to make these systems fair. That is, how to make sure that they work well, accurately on everyone. So if we're fixated on that, we look at, for instance, the source of the errors. Many of these systems today are trained on data sets scraped from the internet. And if we look at these data sets, they're overwhelmingly lighter skinned and overwhelmingly male. Think about who's represented on the internet, who even has the internet, whose faces are we going to be seeing on image search when we do Google search, for instance. It's not going to be representative of the whole world. So this paper sort of, for the first time, I would say, brought that to the fore. So when we were doing our analysis, we wanted to test these systems, and we wanted to first use publicly available data sets, right? Because people have worked on face recognition forever. So obviously there are publicly available data sets that we can use to do our audit. However, we saw that these ones were extremely biased. So for instance, if we looked at the LFW data set that was used before, it was 77.5% male, 83.5% white. If we look at another data set called AGB.A, it was 79.6% lighter skinned. If we look at Adians, it was 86.2% lighter skinned. And so we had to create our own data sets instead. And this is really not a surprise because many of the research publications in what's called a field of computer vision, when they annotate data sets and when they gather the data sets, the distribution of the data sets is really not the same as the distribution of the world's population, right? For instance, very rarely do these data sets come from the African continent, but we have a lot of people living in the African continent. And this can lead to a lot of problems. So for instance, what I'm showing you here is an excerpt from another paper that talks about image classification. And so what they're doing is they're showing the accuracy of image classification systems in different places. So the first photo shows a soap from Nepal, but it's misclassified by almost all of the tools as something else, like food, for instance. Whereas right next to it, you see soap from the UK, which is accurately classified, right? Why is that? Most likely because most of the images that these systems are used to train are taken more from the UK rather than from Nepal. This is another example of an image classification system. Here we see a classification of weddings, right? So the first three are classified accurately as weddings, but the last one isn't. And here we see how it is kind of the Western heteronormative idea of weddings that is encoded in these image classification systems. In summary, visibility is not inclusion. Even if you are accurately classified by a face recognition system, you can still be persecuted because it depends on who uses that system for what purpose, on whom, right? And so the really important thing to take note here is that no matter what kind of products we're working on, we cannot ignore social and structural problems. We can't just pretend that all fairness issues are simply mathematical problems. We have to think about the people behind the mathematical problems. This was the problem with many of the responses to my paper. So I'll talk to you a little bit about them. So some people decided that what they wanted to do was make sure that face recognition systems worked well on everybody. And so what they did was they created huge data sets by which you can use to determine if your system was working or not. So they annotated these data sets by race, gender, different kinds of clothing patterns so that you can test out whether your system worked well on these or not. The problem is that these data sets were scraped from Flickr. And when people put their images on Flickr, they weren't thinking that you were going to use it for your own data set of face recognition. And so some of these people found themselves in this data set and they actually sued. So there was something called the Illinois biometrics law that was violated by these data sets. So this one data set had to be taken down. And then there was another company that determined that it needed to make sure that its cameras also worked well for darker skinned people. So in order to do that, that means they had to test it out on more darker skinned people. But then they were doing this in a very predatory way where people didn't know that their faces were going to be used to be testing these cameras, right? So they didn't give what we call informed consent. And finally, there was another company that said that it fixed its gender recognition tools such that there wasn't so much of a difference in how well these tools worked for darker skinned women versus lighter skinned men. So the error rates were basically the same across these groups. But what did all of these organizations forget? The question, should we even build a gender recognition system in the first place? Is this even something that should exist in the first place, right? They jumped into making it work well for everybody, make sure that the error rates were not different for all the groups, but they didn't take a step back and think, is this even a thing that should exist? And if they read the papers that I read, for instance, especially by people in trans and non-binary communities, they would have come to the conclusion no. So what all of these organizations forgot to ask again is, should this be even created in the first place? So before we jump to making sure that our products work well for everyone, that we equalize the error rates across different demographic groups, etc., we have to ask the most basic question. Should we even build this thing in the first place? If we only make sure that we want to make our products work well for everyone, as in have low error rates for everyone, without even thinking, should we build this thing, we can perpetuate harms. For instance, if we're thinking about massive scale face recognition systems, and the only thing we're thinking about is, oh, we don't have a lot of black faces represented here. And we can scrape the black faces without people's consent, right? So this is happening, for instance, people in Zimbabwe were having their faces scraped for a large-scale face recognition system in China, and they didn't even know. They weren't asked, they didn't have informed consent. And there's a question, would they even benefit from this kind of large-scale system? So in summary, we cannot forget social and structural problems, right? We don't really have to go to China. I just gave an example there. In the United States, there is a report called the Perpetual Lineup from 2016 that I highly recommend. 1 in 2 American adults are in some sort of face recognition system. 1 in 2. And we don't even know. We were not told about us being in these databases. Our faces can be used for anything at any time by any sort of agency, right? So it's not enough to make sure that these systems don't have error rates for us. We also need to know what our faces are being used for. So this is informed consent. Even when we ask, does this system work or not, we have to make sure to look at it in the setting that it's going to be used. If we abstract it out, if we don't think of it as what we call a socio-technical system. So a socio-technical system means you're taking into account who's building the system, who is using the system, and how it's being used. You're not just looking at the product outside of the society that it's being used in, right? So if we look at something as a socio-technical system, it allows us to have a much more expansive view of whether something works or not. So this is, I want to tell you another example from a report called America Under Watch. So this is, I believe, from 2019. And the same group from Georgetown Law that did the Perpetual Lineup looked at all of the uses of face recognition by law enforcement across the country in the United States. And they gave a few examples of such gross misuses. So for instance, one of the things that they do is if they have a suspect, right, they have a suspect for a crime or something like that, they want to have some leads. So they use some sort of facial analysis software to put in an image of a suspect, and so they can get kind of nearest neighbors, other images or people that look most like the image that they put in. So what they were doing is, for instance, they would put in a sketch. That's not how the system is supposed to be used, right? A sketch by a sketch artist rather than a photo. They would even do things like say that somebody seemed to look like a famous artist or a famous actor like Woody Harrelson. So they would say, oh, let's put in a picture of Woody Harrelson. We can Photoshop his eyes for a little bit. And then the system will give us some leads that look more like that person. What does this mean? Then that means you're going to persecute groups of people who look more like Woody Harrelson, right? That's not what the system was supposed to be used for. So when we're thinking about how the system is being evaluated, when we're thinking about whether it's quote unquote working or not, we have to make sure to take into account exactly the domain in which it's being used. So I have spent a lot of time talking about automated facial analysis tools, right? And you might ask me why. Why do I care so much about automated facial analysis tools? Why did I spend all this time giving examples from there? One of them is because of my work, I've seen a lot of different case studies of how things can go wrong. But another one is that this is a very good example of a technology or a system where it might not be so obvious to see the harms. If I talk to you about bombs or guns or something like that are created to kill people, I think it might be super obvious for you to see what kind of harms those can perpetuate, right? But when we talk about automated facial analysis tools, it can be really hard because people can think, well, I recognize faces. I remember people's names. Why should I care about a technology that knows how to do that? Why should I think that it's harmful? I can do that. But individuals cannot recognize, store, connect 6-7 billion people's faces and track them and figure out how they're related to each other, where they're going. Individuals can't do that. We decide who to build technology for, how to use it, and where to deploy it. It's not something that just exists on its own. So what it does is technology amplifies our intent. And if our intent is good, and if we make sure that it's used for good things, they can be very beneficial. If our intent is not that, then it can amplify the harm that we can create. So here I want to show you an example from Life magazine during World War II. This is a picture trying to explain to Americans how to distinguish between Japanese Americans and Chinese Americans. So the point is that people should persecute and target Japanese Americans, right? So it's giving a step-by-step tutorial of how people in the United States should distinguish between these two groups. Now, imagine today we have all these facial analysis tools that are being used to do this at scale. For instance, Muslim minorities in China are being targeted by automated facial analysis tools. Oftentimes, the people who are targeted by these negative intents are not powerful people. They're people who are marginalized. Every society has a certain group that's marginalized, right? And often, these people are not the ones driving the future of technology. For instance, in the United States, it's a lot of Black and brown communities that are targeted by automated facial analysis tools. But if you go to so many of these conferences, academic conferences, for instance, at the forefront of machine learning or computer vision, you will not see many Black people at these conferences. So this is why personally I founded a group called Black in AI. So Black in AI is a nonprofit whose mission is to increase the visibility, health, and well-being of Black people in AI. So I want to tell you a little bit of a story that exemplifies why we have to care about diversity and inclusion and why we can't ignore social and structural problems when we're thinking about building our products in AI. So Deborah Raji, so this is a picture of Deborah Raji. She came to the conference that we hold Black in AI workshops in 2017. And at this point, she was just ready to quit the tech industry. She had faced a lot of discrimination and isolation, and she was gonna just drop out. And she found our workshop and she decided to change her ticket and stay. And then she stayed. She thought that she can find her community there, be herself, and not be isolated. And she stayed. And we're very, very lucky that she stayed because her research has been uncovering all sorts of biases in many different products. And she's been working on, for instance, frameworks on how to audit algorithms. So one of her works actually showed that face recognition systems that are sold to law enforcement in the US have biases, the same biases that were shown in my and my collaborator Joy Buolamwini's paper that I described earlier, right? So what does this mean again? This means that people of darker skin would be much more likely to be arrested wrongfully for a crime, for instance. And after this work was out, and in addition to that, because of all of the worldwide Black Lives Matter protests, there was a moratorium by a number of companies to stop working and selling face recognition systems until there was further regulation. So if this person did not stay in the field of AI, and if she was feeling lonely and marginalized and not herself and unapologetically herself enough to actually work on this, we wouldn't have had this outcome, right? So I'd like for people to make sure to welcome people in marginalized positions in their organizations, because we will not have AI that benefits everyone if we don't do that. So if we don't have people like Deborah Raji in our field, and we don't think about diversity and inclusion as something that is intricately tied with making sure that AI systems are beneficial, we're never going to be able to make sure that we create systems that are not harmful to people. Nowadays, a lot of organizations understand that in addition to thinking about where their data sets are coming from, how their models are trained, how they test their models, they need to make sure to have ethics panels. They need to make sure to have a set of people who determine whether things are ethical or not. A process similar to an IRB. However, many organizations are not ensuring that people at the margins drive these ethics panels, that the people at the margins are the ones heavily involved in making these decisions. And there's been a number of news articles talking about this recently. If we're only thinking about math or data sets or things in the abstract, and we're not thinking about these societal and structural problems, we're not going to be able to make sure that our products are safe for everyone. So to summarize, what are things that we should do? How should we approach the product development cycle? First, we need to have inclusion from the start. Not at the end, not after you've built the whole thing, but from the very beginning when we're asking, should we build this thing in the first place? Because as we first saw in the beginning, two different groups of people can have very different experiences with the same technology. And if we don't have the experiences of people at the margins in the beginning, we're not going to be able to know what the potential harms are before we actually decide to build something. So not at the end, but at the very beginning. Secondly, we have to make sure that we are explicit about the values that we're encoding in these systems. I don't believe there's any such thing as a completely unbiased system, but we have to understand that every decision we make on all aspects of the product lifecycle, we're encoding some of our values into those things. So what are those values? We should make them explicit. What do we expect our models to be used for? Why did we want to create the products that we are creating? Document our process. For instance, there is a way to do this called data sheets for data sets, which I myself wrote. It's a framework that we can use to document our data annotation and gathering processes. Model cards are a similar process for modeling choices, right? What are some of the potential harms that we foresee along the way? What are the ethical considerations that we have? We also always need to be working with a domain expert when we're building our AI products or systems. If it's something to do with health, we have to be incorporating healthcare professionals. If it's something to do with art, we need to be working first and foremost with artists. If we're only thinking about our products in the abstract, then we'll have failure cases that we don't know about. We'll only know about these failure cases when we're working with the domain expert and looking at the specific domain that our products are being used for. In order to make these value systems explicit and incorporate diverse voices, there is a design methodology called value-sensitive design. There is another methodology called the diverse voices methodology. So I highly encourage everybody to look into these methodologies and incorporate them. There is a paper called Abstraction, Fairness and Abstraction in Socio-technical Systems. And it talks about how if we ignore these systems, if we ignore social and structural problems and only think about our product in the abstract, we can actually perpetuate the harms, right? While we're thinking about we're fixing issues, but we can actually perpetuate the harms. And so these are some of the examples I tried to give earlier. Don't force people to use a system they don't really understand, right? This is the point of informed consent. Allow them to opt out. This is called the politics of refusal, and some designers actually call it tinkerability. Give people options in your system, and don't build it so that they overtrust it. There's something called automation bias, where people can overtrust a system. Actually, Ayanna Howard, who was at Georgia Tech when she was doing this experiment, did an experiment with a robot that was guiding people out of a simulated fire. So in the middle of the experiment, they had a simulated smoke. So people thought the building was on fire. I have no idea how you can do this kind of experiment, but they did it. And the robot was trying to guide them into safety. So the experiment was to see whether people just trusted the robot and followed it wherever it took them, right? So it would take them towards the smoke rather than away from it. It would take them to random corners of the room, and people just followed it because they over-trusted the robot. So do not make your systems such that people over-trust their capabilities. You want to calibrate it such that people have an appropriate amount of trust and not over-trust it. So this is called automation bias. Avoid automation bias. And finally, I want to talk about regulation. Some businesses are scared of regulation because they think it might stifle innovation. I think that regulation actually does not stifle innovation. What it does is it levels the playing field for everybody, right? So if one organization is prioritizing safety, if one organization is spending a lot more time and money to test out their models by different demographics because they want to make sure it works well for everyone, if one organization is spending so much of their time gathering and annotating data sets and documenting and putting in resources there, another one isn't, that means the organization that is prioritizing safety and mitigation of harm is going to be at a disadvantage. So what does regulation do? Regulation makes it such that all organizations have to prioritize safety. So I think people should advocate for regulations such that all organizations have a level playing field and they prioritize safety. So I want to remind everybody that this is really not a problem that's unique to AI. We've seen it before. For instance, if you look at cars, automotive systems, we had many of the same issues. And there was absolutely no regulation for a long time, right? People didn't have to have seatbelts. Car companies didn't have to make sure that their cars had shock absorbing systems. We didn't even have to have driver's licenses, right? You didn't have an age limit of who could drive. And that's where we were when cars were first created. And over time, we had to make sure that the cars were safe. For instance, even crash test dummies, the dummies that they used to crash test cars, had prototypical male characteristics, right? So many accidents in cars actually disproportionately impacted women and children. Another good example is drugs, medical systems, for instance, and drugs. Many of these drugs were not tested on disaggregated groups. So for instance, when people developed drugs, they were not required in the United States to make sure that they had the same kinds of side effects on, for instance, women or people of different races, or for instance, Black women and Asian women or Asian men, white men versus other groups. So what does this mean? It means that when you test out your drugs that work well for one group of people may have disproportionately bad impacts on another group of people. Even as late as the late 90s, early 2000s, 8 out of the 10 drugs that were pulled out of the market disproportionately negatively affected women. So again, this is not a problem that we've only seen in AI. And so we can draw from other industries. We can learn from what other industries have done, right? So for instance, for drugs, we have the FDA, right? We're not afraid of the FDA. The FDA has to approve all the drugs that go into the market so that they're safe for everyone. So I want to close by saying, let's not be afraid of regulation. Let's prioritize inclusivity from the start. Let's make sure we prioritize voices of people from the margins. Let's make sure that we make our value systems, our value judgments explicit and document them. So we can use data sheets or model cards for this. We can use the diverse voices method or value sensitive design method. Let's make sure that we think of a socio-technical system. Again, let's not make our products abstract. They work in a specific society. So let's make sure that when we test out our products, we take that in mind. Thank you.
Dr. Timnit, thank you so much for such an engaging presentation and also agreeing to hang on for a few questions. To not waste your time, I'm going to jump straight into it. It was fascinating to hear you talk so passionately about past mistakes and bias and how the underlying data in AI applications has been done. I'm sure a lot of our viewers are now trying at the moment to think about applying artificial intelligence within their organizations. Other than looking at the underlying data is the right thing to do, what other reasons are there to do this other than, let's say, reputational impact?
I think that reputation is one, but there's also the fact that the product will work much better if we make it A, safe, and B, make sure that it doesn't harm the communities that we want to serve. So it ends up that if you spend more resources asking where your data is coming from, who is benefiting, who's not benefiting, who's represented, who's not represented, the product itself will be much better. So we might not see the shortcomings of our products if we're not thinking about bias, right? But that's just being short-sighted. In the long term, in the long run, if we have processes in place that make sure that we're testing out different aspects of our product, we're thinking about whether we should build something that serves most people versus not, it's going to make our products much more robust and much better generally. It's not even just about bias, but we'll end up creating better products.
Okay, that makes perfect sense, and I don't think you could have given a better answer than simply building better working products. That's something that everyone can relate to. So assuming now that everyone who's listened is absolutely bought in and wants to adopt artificial intelligence technologies within their organization, what are the questions that they should be asking the teams that are implementing these solutions now?
So I want to first start off by saying that the capabilities of AI are very, very overhyped at the moment. And so people need to be skeptical. When you hear about technology that's just doing magic and it doesn't pass, quote unquote, the smell test, then you should be skeptical. Don't rush to adopt it. For me, that's the very first kind of point I want to make. We don't have to use AI on everything, right? It's not a hammer that should be used on every kind of problem for every nail. So we should first look at the problem and we should ask, is AI even something that would help us with this particular problem? I want to give you an example of how overhyped it is. There are some startups right now that feel the pressure to put AI on everything, that they've hired people to pretend to be the output of an AI system, right? So that is how overhyped it is. So my first thing that I want to say, my first message is just don't buy into too much of the hype. So now when we take out the hype, there are some questions that might be best answered with the assistance of an AI system, right? And we'll only know those if we work very, very closely with domain experts, right? If you're creating a system for art, you have to work with artists and think about that community. And if this is something that works well for them, then you use it. If it's not, then you don't have to use AI. So that's the very first question I would ask. Should we even use AI here?
Okay, I'll be honest, I wasn't quite expecting that response. Actually questioning the validity of whether an artificial intelligence system should actually be used in the first place. But it makes sense the way you explained it. I just want to go and wrap things up now with a final question and link it back to the whole theme of today. So today we've had a number of keynote speakers, such as yourself, talking around digital trust as a topic. What does digital trust mean for you?
We want to create a system that people don't overtrust or don't undertrust, right? So for instance, I've written about machine translation systems where the translation is completely inaccurate and people use it in high stakes scenarios. And there were even people who were arrested because of an incorrect translation, right? So if you want for people to appropriately calibrate their trust of a system, you want to have warnings saying, hey, our system is not 100% accurate, or hey, don't use our system in these specific ways, right? So that they don't overtrust it. And if they're under-trusting it, then you'll want to similarly help them appropriately calibrate that. So for me, the idea of transparency is more about calibrating the trust, right? And not over-trusting. And accountability is something that might feel like it takes too much time for us in the beginning because maybe we haven't set up those frameworks to hold ourselves accountable. But really, we're helping ourselves make more robust, better systems, right? When we have these different processes in place where we're asking, what are we building? Who are we building it for? How are we testing these things? In the long run, we're making it better for ourselves. But of course, there's growing pains. So in the beginning, when we're setting up these processes, it means that we need to spend more resources. We need to hire more people. We need to put in more money per thing, right? And that might make us feel kind of uneasy. But we're kind of making ourselves a little bit more robust for the future.